Today we will be talking about objects and classes. This is the heart of object-oriented programming. It is really what makes object-oriented programming different than the other models of writing code. Programming in the object-oriented way is a way of writing code to simulate real-life objects, like, creating houses in software, of course. What happens in this case is that you might create a blueprint of what your house should look like. And then, based on the blueprint, you could produce one house after the other, and every house could be looking a little different than the other ones. So here is the blueprint one might have created about the house. And then based on this blueprint, making some changes, you could have this house with this kind of shingles in the front, or you could have this house, or you could have the other house. So yeah, it looks weird in the beginning because we're thinking of code as commands operating on data and producing results, the way that usually mathematical functions work. But in object-oriented programming, the idea is that you are actually creating prototypes, and then based on these prototypes, you produce objects that behave the way you would like your prototypes to behave. So the basic building block is an object, and the way that you are defining object is through classes. So a class is the blueprint that allows you to create many different objects. Now, every time you're producing a new object, we say that you instantiate an object. That's part of the terminology. So an object has two things, has a state and has behaviors. State is the collection of variables or attributes that describe the house. So it could be the height of the house, it could be the color of the shingles in the front, it could be the size of the door and things like that. And then the behaviors would be things that apply on the state and change it. So the behaviors could be like, paint the house, and that would, provide the color to paint that house blue, or paint this other house, this other instance of the house, this other object, in other words, paint it gray, etc., etc. So the way that we are managing the state is through a set of variables, and the way we manage the behaviors is through a set of methods. In this picture, we can see how the code for a class looks like. A class is a file. Usually a file contains just one class, and it has a bunch of data in the beginning. Here where we're declaring the data, this is the state. And then it has a bunch of methods. These are, you can think of them as functions, but these are the behaviors. This is when you are applying some algorithms to the data to produce some results. The object is what a class will produce when the data get some specific values. So a class contains data declarations and method declarations. An object is an instantiation of a class, so it is a class with specific values. The values of the data represent the state of the object, and the methods, the way that the methods work, define the behavior of the object. Let's try to think of examples of classes you could create, an object you could create. Imagine that you could create an object, let's call it coin. All right, you have to figure out what does a coin needs to be represented. Well, it needs to have the face inside, maybe the denomination, maybe the size, maybe the metal that it is made of, etc., etc. And then the behaviors are what can apply on the different data that a coin contains and do something with them. So you could flip a coin, and that will tell you whether it came, let's say, heads or tails, if the coin had these kind of defined values. Or you could have a class for a student, all right? And you can imagine the kind of data that you would like to know about a student. You would like to know the class year that she's in. You would like to know maybe the dorm that she's in. Maybe you would have a picture of that student, etc., etc. And a method that applies to this student would be, for example, the method register, in which a student registers for a particular class. Here is an attempt to define the class coin. We could define it in many, many different ways, depending on really the kind of functionality we want this coin to have. But in this very simple way of defining a coin, we want to use a coin in order to flip it. We don't care the denomination, we do not care, the metal that it is made of, etc., etc. So we might have a value to define whether it is heads or tails. And here we have made a determination that heads has the value of 0 and tails has the value of 1. So we define it as an integer, but it could be also a Boolean, true and false. We could have another variable called phase, which is the current side showing. So a coin could be heads or tails, but the particular phase is what is showing at this point. Is it heads or is it tails? So phase could be either heads or tails. As I said, we could have a method flip, which would kind of randomly select either heads or tails and assign phase to these heads or tails. We could check to see if the coin is heads, and that is a method that's producing a Boolean result. So if it is true that it is heads, that is the phase is 0, then this would produce true, otherwise it would produce false. Every class would like to have a method called toString, which produces a string representation of these particular objects of coin. So here we can produce anything we want in a string format to represent the state of this coin. Something we will learn soon is that every class in Java has also a constructor. Notice that the constructor has the same name with the class. This is what is executed when you get a new coin, because this is the blueprint of coins. This is a class, it is a blueprint. You can create one coin after the other after the other. You want to play, let's say, a game with 5 coins, that you would like to flip 5 coins all at once, all right? Well, you can do that by producing 5 times new coins. So that is the method, the constructor, that will give you a new coin. And what does this new coin do? Well, it will determine the phase of each one of the coins. Pretty much it will determine what is the phase each coin is showing, and in other words, what would be the value that this coin has. So that's a first look at a class for a Java object called coin. Let's define another class similar to that. We call it a die. Now, a die has 6 different sides, not 2 as a coin has. So we would need to have ways of representing, this value that would be the phase that the die is showing. By the way, when we have multiple dice, we call them dice, and one is die. I know that has a weird name if you never encountered before, but that's a die is a one single object of type dice. So, what should be the state of the die? Well, we would like to know what is the face that it's showing, right? How about the behavior? What do you do with the die? Well, you want to roll it. There might be other things. You might want to create a very fancy animation which would actually visualize dice rolling. You could add those in your class, but you don't have to. You don't need to, when you define a class, you don't need to define the perfect class that has usage for every possible, that has data for every possible usage of the object you will be creating. If we just want to create dice so that we can use them to play games, all we care is, what is the face that they are showing when you roll them and what happens when you roll them. So we will design a class in Java called die, and by doing that, we will be able essentially to reuse our resources of the dice. That is, once we define a single die, then we can reuse it and instantiate multiple dice. So here's we're rolling two dice. One happens to roll a 3 and the other happens to roll a 4. What happens inside the code that represent these two dice is that we will have a variable, let's call it die1, which represents this first die, and it has a value, the face value, which contains the number 3, which is what this die has rolled, and another one, which represents the number 4, which is what this other die has rolled. Now, what is the big deal about creating classes? This is challenging to understand right now because you have not learned the history of attempts to create programming languages and how things have gone wrong. One of the ideas that we hold high in our hearts is the idea of encapsulation. Encapsulation means to protect your data. And protecting the data means that when you're creating a die and this die has a face value, you don't want those programs that will be using the die, we call them the clients, you don't want them accidentally or intentionally to abuse the data. So if you roll the die and it got you the value 3, you don't want a program that uses this die to accidentally or intentionally change from 3 to, let's say, 6. That would essentially compromise the usability of your code. By encapsulating an object, it means that we think of it as a non-transparent box. So a client using here our code, the die, cannot actually have access to our variables. It can only have access to methods, and only those methods that we will allow a client to use. Only the methods can access the data, and that way we can protect the integrity of our data because we can defend them through our methods. Any client who wants to use this die can only do it through the methods that we are providing. If we do not allow the client to go and change the value of the die directly, the client will not be able to do that, so our data will actually be defended. If the only thing we allow, let's say, through our methods is to roll a die, The client can only roll a die, cannot go and change the value instantly to the value that it likes. So that's the idea of encapsulation. It enforces access to an object's data only through specific methods that the class has defined. So it protects the class implementation. Before object-oriented programming, we were thinking of data as just out in the open, and programs could go and change the data, and hopefully they do not abuse them, or accidentally they do not destroy them. But this is not easy to be protected and maintained. You have already seen in the code we have shown you so far the terms public and private. Here, for example, class coin is public, and variable face is private. And these other methods are public. All right, so here is using the term private, in this case for this piece of data called face, and we use the word public for these methods that the class has. So we usually declare variables as private, like the variable face we showed before, because that way we enforce encapsulation. In other words, a client cannot go and change the face of a coin without going through a particular method. The particular method in this case would be the method flip. The methods, some of them, we will call them public, which is what the clients will be allowed to use. So many classes, you will see that they have their data declared as private and their methods declared as public. Actually, you could have private methods. These private methods are there. They're methods to make the coding easier, not to be used by the client. So if I'm writing a method, a public method, and turns out that it is a kind of too large and too complicated, and I would like to break it down so that I can program it a little better, I may want to break it into using other methods, and these other methods, sub-methods you could say, and these other methods would be private. You don't want the client to use these other methods. They are there only for me who is writing these public methods. But we never declare variables as public, because that essentially opens the door to all kinds of abuse from a client program. There is public and private are called visibility modifiers, and there is one more that we will talk later in the course. It's called protected. So here we are back in the die. Now, something that might surprise you is that when we try to design a class like the class die, we start by writing code for a client program or a driver program, sometimes people call it, but for the client who will be using this class. Because we want to know how the class will be used in order to figure out what exactly we need to put into this class. So here we are rolling 2 dice, and we will play the game Snake Eyes. And Snake Eyes will just try to figure out how many times you roll 2 dice and you get both 1, all right? By writing, this is going to be a game. By writing code for this game, Snake Eyes, will give us the opportunity of actually figuring out what the class die should contain. So the game will be rolling 2 dice, die 1 and die 2, and then we'll be checking to see if die 1 had rolled a 1 and die 2 had rolled another 1. And if both have rolled 1, then it could count that it had got another Snake Eyes. I guess If you have enough imagination, you could see that these double ones look like the eyes of a snake, though many animals that I know have twice. Anyway, forget it. So here is the client program. This is public class snake eyes, which is really the client. How do I know that it is the client? Well, here is a big hint. It contains a method main, which means it is the part of the program that will be executing and will be using a die. So what I will be doing, as I said, is that I will be rolling two dice, and I will be checking to see if these dice both have gotten one. So the first thing I need to do is create two dice, and that's what I will do here. I will create die 1, which is going to be a new die, and die 2, another new die, and now I'm ready to roll these dice, right? Notice that I'm writing the client and have not shown you yet the code for die. I may not have even written the code for die, but that's okay. That's okay. We just need to figure out how the class die will be used to produce objects, and then we will write this method. So we're ready to roll. Now we will be rolling for a number of times, maybe 500 times, and we will be assigning the face values that we got from the roll into num1 and num2. So I rolled die 1 and I assigned it into this variable num1. Here it is. And I rolled die 2. And now I'm ready to see if I got both ones. If both num1 and num2 were 1, then I will increment my count. Count is really what I use in order to figure out how many snake eyes I have got. So here, look at this for loop. It will be rolling these two dice that I created before I started. It will be rolling them 500 times, and then we'll be checking to see if they're both ones. And every time it found that they're both ones, it will increment the counter. At the end of this for loop, we are ready to finish. We'll say how many times we rolled, how many snake eyes we got, and we will calculate, let's say, the ratio of count of snake eyes over the rolls. All right. So again, this is the client. Notice that the client is using the constructor for die. This is, the new die. It is rolling a die, and it is not. We do not have the code yet for die or for roll, but that's okay because the use of this class will tell us what kind of methods we need to implement. So a constructor is what is used whenever we call new. So this is the constructor. Notice that it is returning something of the type die. It has no return type, notice. So when we define it, we will provide no return type. And it is a common error actually to create a type as the return method because that makes it not a constructor. I'll show you what I mean. You do not need to define the constructor, by the way. And if you do not, Java will create a default constructor that essentially will just initialize your variables to their default values, usually 0 or false. So here is the class die. All right. It has a face value, and we keep in mind that we have this constant max because we do not want a die that has more than 6 face values. So here's the constructor. Notice that the constructor has no return value. What do we do in a constructor? We just provide a particular value to our instance variables that have no value at this point. The instance variable face value has no value, so we'll provide the value 1. So when we are creating a new die, by default, we give it face value of 1. We don't have to, but this is what this piece of code does. And then we have this method roll. That's the other thing we need in order to run snake eyes. And the method roll creates a random number. and it's a random number that's supposed to be between 1 and 6. And because random produces an integer between 0 and 5, if we give it max to be 6, then we will add 1 to make this range from 0 to 5, 1 to 6. And then the roll will return this phase value. Right now, we have all we need to play the snake eyes game. Do we need more methods? Sure, why not? We may need a method, for example, to print what a die looks like. We could, just have a string that says the value of this die is, let's say, 3, or we could even have a toPrint method that will draw a nice little die using kind of characters on our keyboard, like dashes and stars, to produce the look of a die. So here are other methods that a die could have. Set value, which we could go and assign the value of the die to whatever we give. Well, up to a point, we may not want to assign a value that is not greater than 0 and at the same time less or equal to max, because otherwise we will be creating a die that's not valid. So this method set phase value will actually make sure that if we try to set the value of a die to something like 23, it will not allow it. So what if we try to call set phase value with value being 23? You may want to think about what would happen here. And so what would be the phase value after this code is being executed? Here is another method, get phase value. And this will just tell you what are the contents of the variable phase value. And the toString will just, present really as a string the phase value. So if you have a 3, this 3 will become a string and will return it as a string. Notice that this is calling the method toString in the class integer, which is not int that we usually use, and I will explain in a second what that means. All right, so now we have declared several methods for our class die. We have declared the ones that we knew were needed in order to play the game Snake Eyes, but we have declared a few more, which could be useful. Is this the best implementation we could have for a die? Well, actually, no. Here, for example, whenever we create a new die, we immediately give it the value 1. Think whether this is a good idea, to create a die that by default gets the value 1 for the face. If you were writing the client, like the Snake Eyes, and you knew that die operates like that, could you actually exploit it? Think about that. Another place that this particular implementation of die is not the best possible is the following. Notice that set phase value is public, which means that we allow the clients to change the value of a die. Sure, we try to protect the phase value to be nothing else other than an integer between 1 and 6. But is it something we want to essentially have a client declare the phase value without rolling? There is no perfect answer to this question. Sometimes it is good not to allow clients to create or assign particular values on a die. But for other games, for other uses of die, it might be just fine to do it like that. So be aware, however, that by declaring this public and not private, you are allowing the client to change this value. The other thing that I would like you to pay attention here, you may have seen this already, is the way we write documentation. Notice that we start with slash star star and we end up with star slash. And in here we write an explanation of these methods that we have. So this is face value mutator, only modified if the value is valid. So we give a description about what this method is doing. And then we are describing in the add param, what is the parameter that is getting here, the parameter value. So param value is described as die is set to this integer from 1 to max. When you write comments in this way, we call these Javadoc comments, then Java will actually produce very fancy, professionally looking documentation for you. Now, a quick way of understanding what a class contains and how it is used is through these UML diagrams. A UML diagram describes, let's take the UML diagram of a die. So this box here describes the class die. This is the name of the class, and it tells you the instance variables that it has. So it has max, which is this constant, which has by default value 6. And it has face value, which is an integer, which does not have a preset value. These two minuses in front of them means that both of them are private. So these are the instance variables that are private, and you use a minus to distinguish from the pluses here, because the pluses here describe the methods under this second line, the methods and the visibility. So plus means that role is public, anybody can use it and produces an integer. Set face value is another method. It is also public, a client can use it. It takes as argument an integer and produces nothing, returns a void. Get face value takes as argument nothing and produces an integer, and it is public. And toString, of course, produces a string, and it is public. Now, Snake Eyes is the client that uses, that's the meaning of this arrow here. Snake Eyes uses a die. And by the way, a die uses the random number generator class from Java. Random is inside Java util. And Snake Eyes, we can tell that it is a client because, as you can see, it has a main method. That's the thing we care about, which will essentially use one or more dice. A little detail about what is going on here. Notice that face value needs to be presented as a string because toString needs to return a string, but face value is an integer. We need to have some way of converting that integer, face value, into a string in order to return it. This is done through this class called integer. So let me explain now what this integer means. As you remember, in Java, we have these primitive data types like int, float, double, char, boolean, and long that I have forgotten to write here. These primitive data types are not classes, are just a little piece of memory that represents just an integer number, let's say for int. In Java's philosophy, everything should be a class. Int as a primitive data type is not a class. So Java provides so-called wrapper classes, which contain not only space for a particular integer to be held, like face value, but also contains methods that would apply to particular integers. So inside integer, you may expect that you will find a method called string, toString, which would actually produce a string for anybody else to use. So that's what the class integer is. It is a collection of methods. It's a class which contains not only an integer, an int, but also a collection of methods that, for example, could be useful in converting one item of the class to another. So that's the idea of the wrapper classes. And they can be very useful whenever you want to convert between one primitive type to the other, because it can save you a lot of frustration and errors when you make the conversions.